Okay, here we are in lesson 10.8, and we're going to primarily factor by grouping. This is going to prepare us for our lesson 10.6. Before we begin factor by grouping, I mentioned in previous lessons that we should always look at our expression and see if the first and last terms are perfect squares, and if so, we might be able to use our special products. And we also should look to see if we can factor something out. So here we can see an 11x squared can come out. The next thing you would do is look at the remaining expression in the parentheses and see if we can factor that further, and we cannot. All right, take a minute, pause the video if you need to, and see if these two expressions are factored completely. Okay, so hopefully for the first example, you would say, yes, it is factored completely. X squared plus 9, we have perfect squares, but we cannot factor it further. The second one is the difference between squares, so that one is not factored completely. Let's see how we could finish that one. We would say 4. We know the first term has to be x. And we know that we would say plus 3 minus 3. Then if we FOILed it, we can check it. Positive 3x, and our middle term should cancel. That's why we make one positive and one negative, and there's our negative 9. And then, of course, we bring down the 4. And again, these two are going to cancel. Okay? All right, factor by grouping. So when we have 4 terms, we're going to group. So we put parentheses around the first 2, and you can rearrange them if you want. Just make sure you're careful with the signs. And what is super important is that we put a plus sign in between these 2. Now we're going to look at the first parenthesis and factor out anything they have in common. And we look at the second parenthesis. So we were able to take out the x squared, and we were able to take out a negative 36. Now we take our leftovers. They're going to become one parenthesis. Our lookalikes will become the next. And then once again we say, is this fully factored? And when we look at x squared minus 36, we say, nope, that's the difference between squares. We can factor some more. And then if you were asked to solve, in this case we're not, but if you were asked to solve it, we would have the expression set to 0, and we would use our 0 product property. X minus 6 equals 0, x plus 6 equals 0, x plus 2 equals 0, and then solve it. So x would be equal to 6, negative 6, and negative 2. But we didn't have to do that on this particular question. Okay. All right. Pause the video. Check and see if you can do this one. All right, so notice we have the word solve, and our expression is now an equation, and it's set to 0. So we ask ourselves, is there anything I can factor out, and or do I have perfect squares at the beginning and the end? In this case, hopefully you took out a 2x. Now we look at the 4x squared minus 9, and we say, can I factor that anymore? And we could. And the final step is to set all our expressions that have a variable, we set those equal to 0. We're going to use our 0 product property. And these should be the answers that you got. So we ended up saying 2x equals 0. Then we said 2x minus 3 equals 0. We added 3 to both sides. 2x equals 3. divided by 2, x equals 3/2. So that's where this one came from. And then we do the same thing to the last set of parentheses. And I'm going to go back to this first one, just in case anyone isn't sure where we got the 0 from. If I divide by 2, x equals 0, because whenever we have a 0 in the numerator, 0 divided by 2 is 0. Okay, so these are the different ways we've looked at. We looked at graphing, and graphing is nice because you can approximate, you can actually see the direction. We looked at bridges, we looked at dolphins jumping, the quadratic formula. We looked at factoring. All right, pause the video and see if you can do these. Okay, so for the first one, this one was a factor by grouping one, and I rewrote it so I could squeeze in this plus sign. And we take out the greatest common factor. And sometimes the greatest common factor is going to be a 1. You always must take out something. In this case, we didn't have to worry about it. The next one was just factoring out your 5x and then factoring out your trinomial. The third one is probably the trickiest. Once I factored out the 3x squared, sometimes students forget that 1 is a perfect square. So we had the difference between squares, and I could go ahead and factor it fully.